Okay, so instead of section 4.7, the examples in 4.7 I didn't think worked as well as these ones that I've made. So we're going to do these examples. I'll still give you questions that you can do from section 4.7. And what we're going to look at today are max-min problems. It's kind of an idea that calculus does a lot. So once you take calculus either in university or if you do take it next year in grade 12, you'll see that a lot of times you want to find out what is the best thing to do. Like, what shape should I make a Coke can so that I can maximize how much liquid I can put in and minimize the surface area or the amount of materials that I need, so that I can spend less money on my materials but still cover what I need to do. Okay? What should the Winnipeg Jets charge for hockey tickets? What should they charge for seasons tickets? Okay? What should they do to maximize profit? They look at data and then based on that figure out this should be the price of tickets so we can make the most money. And they look at things like that. And that doesn't always mean you sell the most. Sometimes if you can sell less but sell it for more, you can still make more money than selling more for less. So that's what we're going to look at today, is some applications of this. All of our questions will make parabolas. And the nice thing about parabolas is sometimes a parabola has a maximum and sometimes it has a minimum. And so we'll see how this equation makes those values. So here's one that we've done already before. We've done it a little bit with our graphing calculator, but it's a question where an equation was given. Find the maximum height of a ball thrown from one friend to another if it follows this path. H is the height of meters, and t is the time after. And what we'll do is we'll solve by completing the square, because if we can complete the square, then we'll know where the vertex is, and if we know where the vertex is, we'll know where the maximum or minimum is, and we can graph the situation. So should I give you a head start for completing the square, or do you want to just do it together? Just do it together? All right. A little bit, right? Instead of adding on both sides, now we add and subtract on the same side, is one of the things. And the other thing that changed is our goal is to change it to look to this form, right? That's our goal, because if it's in that form of the quadratic function, then we can tell what the vertex is, we can tell if it's going up or down, and we can graph it easily. So our first step to make it look that way is to factor out the a value out of the first two terms. So if I take a negative 2 out, I'd be left with t squared. I guess this is an h over here for height. If I take a negative 2 out of 4t, I'm left with negative 2t. And finally, we have plus 9 outside.
Don't forget to leave spaces to complete the square.
And then we can leave spaces. And the first space, how do we fill in that green space?
Divide the negative 2 by 2 and square.
Divide negative 2 by 2 and square. So we'd get negative 1, and negative 1 times negative 1 is positive 1. That first space will always be a positive number, because you divide by 2 and square. Now what have we actually done by filling in that space?
We have successfully subtracted negative 2.
We have successfully subtracted negative 2 from that side, because that negative 2 in the front will hit that 1.
We subtracted 2, we didn't subtract negative 2.
Yes, you're right. We subtracted 2. Yes? We divide, to get this number, we take this one, divide it by 2, and square. Then, once I fill in that number, 1, and I want to see what have I done to that side, because I've changed that side. I've actually subtracted 2 on the right-hand side of the equation. Because when I put a 1 inside here, that 1 would get hit by this -2 when I distribute.
Oh.
Okay? Because now if I were to distribute at this point, -2 times t squared, that makes the -2t squared. The -2 times the -2, that makes the plus 4t. But now I have an additional -2 on this side.
So you may find that you have to add 2 to...
So we add 2, so that basically cancels out. So we haven't done anything. But what that allows us to do now is change our equation to be h equals -2 t minus 1 squared plus 11. And now we know, and we can graph this. What's our vertex? One comma 11 would be our vertex, right? That's just the vertex. Which way does it go, up or down? Down because of the -2, which means we can go over 1, down 2. That would put me at the point 2 comma 9. If I went over 1, down 2 the other direction, I would have 0, 9. What would be the next thing you do? Over 1, down 2, over 1, down 6. Because normally it's 1, 3, 5, 7, ... right? That's if the a value is equal to 1. Our a value is equal to 2, so all of these numbers would get doubled as far as being able to graph it. So our parabola looks like this. I'm only going to draw this amount of it because we were throwing something in the air. We can't go back in time.
That's what you think.
And so this is what would be a reasonable thing. What is, the question says, what do we want to find? Find the maximum height of the ball. So the maximum height is 11, and what are the units that we're using? Meters or kilometers? Oh, good. Because that'd be crazy if they threw it 11 kilometers in the air. Okay. The maximum height is, yes, that is an S. There's normally arrows on the graph, but I didn't draw arrows on this one because it doesn't make sense to go in negative time, and it doesn't make sense for the ball to go into the ground. So in this case, I drew it without the arrows because that is a situation, and this is where the situation would make sense. I wouldn't take marks off if you drew the whole parabola and put arrows on.
What does the +2 at the top like cancel in the other side?
This +2 in green here, it cancels out with this +1. Because this +1, see the black arrow, gets hit by that -2. This is going to be the process for all of our questions. We're going to always have to complete the square so we can graph it. Once we've graphed it, then we'll be able to see what the maximum or the minimum is.